Hello, I'm Michael Lincoln. I'm studying for a master's in chemical engineering at K-State. As mentioned, I'm PPI intern for Common Aerostructures. And first of all, let's figure out if this is the right button to go forward. It is. All right, good to know. So first of all, I'm PPI intern for Ducommun. This specific plant I was working at is in Parsons, Kansas. It is a city of about 10,000 people. What's notably there is the Parsons State Hospital, Big Hill Lake, which is a pretty big lake actually, and it even has its own little beach there if you ever want to visit it. They even have like parasols and stuff. And the Kansas Army ammunition plant. It's located in the most southeastern part of southeast Kansas, basically. And currently, the area has some local electronics and metal recycling. In fact, its metal recycling is quite big because there's a lot of metal processing going around the area. Notably, Ducommun is actually a big part of that. The Ducommun plant itself, this is just a picture of it. It is a lot bigger than it looks, especially from the inside. Specifically, Ducommun, the company, deals with aerospace and defense and industrial markets. Specifically, just makes a lot of space and aerospace parts. The Parsons plant employs about 130 people, and they specialize in titanium parts. And that's basically what they do 99% of the time. They make titanium parts for airplanes. Notable pollutants from this plant includes mixed acid, VOCs from maskants, chromium, plastic water bottles, garden abrasive, and spent PPE, which usually comes from the painting booths that use the hexachromate paint. The PPI internship, just as a brief overview, Ducommun requested a PPI intern for summer 2022. I'm actually continuing on the work of the previous PPI intern named Sophie, who was there in 2021. Ducommun specifically mentioned that they want to reduce their environmental footprint, which is something that even the corporate wants through their ESG report, and they just want a fresh set of eyes on their process. The Ducommun process is very complicated because they do not have one process line. They have something like 4,000s because they make thousands of different parts, and each individual part goes through various areas, as you can see through this, what is colloquially called the spaghetti diagram. It goes through a lot of steps before it is finished. For each part, it's a little different. So this is a pretty general overview of what any single part goes through. Just generally speaking, there is not really one process, but a lot of different parts being made through a lot of different ways. So generally speaking, this PPI internships focused on, let's just say, the individual unit operations as opposed to the process line entirely. So the projects considered for this PPI internship were listed as followed. I'm not going to cover it now because we're going to go through it in the following slides. First of all, from the 2021 internship, it was recommended that Ducommun apply for the KHE Environmental Stewardship Award. The most of the paperwork's filled out. However, the award got delayed due to COVID. I just did some light editing and submitted it on their behalf, and they did actually win the award, so good for them. This was just a quick project that took 3 hours. So, secondly, the plant has a lot of lighting. Specifically, they have a lot of inefficient and redundant lighting. This produces needless Scope 2 GHG emissions. For those of you who don't know, Scope 2 GHG emissions are just the emissions associated with utilities. That can be the energy emissions associated with producing energy for lighting, or like the energy required to pump water to wherever it needs to go. Specifically, I looked at replacing the fluorescent lights that are currently used with LEDs, turning off any quote-unquote pointless light, and maybe adding some motion sensors to some areas. The specific methods used were using hobo data to determine which areas had sort of low occupancy, and just sort of looking around and saying, okay, does this light light anything, or does this light anything important? This picture is actually a pretty good example. The light that I have circled in orange, that's just illuminating the roof of that box, and no one ever goes up there, so it's not doing anything. And so that's an example of sort of pointless lighting. The results were found that honestly there were some opportunities with motion sensors, and there were some opportunities with turning on quote unquote pointless lights. However, replacing it with LEDs would have major impact. However, it was found to have a really, really high long return on investment. Specifically, I think it found something like the ROI for that was 14 years. And that's part of that was because of the cost of the LEDs themselves, but also just the plant is so old that no one's quite sure how the wiring works. And the wiring is often having multiple lights in a row sort of on one wire. So if you interact with one light, you're really interacting with like 20 lights at the same time. So there would be extensive rewiring needed to have that reworked. However, despite that, I still recommend it because there would be significant environmental savings. Specifically, you would save around $20,000 a year in reduced carbon emissions by 228 metric tons CO2 equivalent. Probably the more let's just say infamous process at this plant is the chemical milling optimization. As part of creating titanium parts, they have to dunk their titanium parts into a very, very nasty acid bath, and that just sort of etches it at a slow rate. And it's like the only way to really etch titanium in such a consistent manner, which is why it is used at all. This also produces a lot of very hazardous mixed acid waste that's both environmentally hazardous and also costs the plant a lot of money to dispose. Specifically, I looked into mixed acid waste reuse, sort of adding a backflow on one of the lines because it turned out one of the cleaning did not have a backflow in it, a closed loop water system on their cleaning lines, some chemical drag reduction techniques, and it was sort of brought out by one of the chemists that worked at Ducommun that you could actually add sodium hydroxide to that mixed acid waste to produce titanium dioxide and sodium fluoride, both of which are used in other industrial processes. So it was maybe a potential way to add a new product line at the plant. There were, for all these processes, various things happened. I contacted companies with mixed acid waste reuse systems to see which one could be used at the plant, talked to operators to see if there was any ways to make the plant, like the chemical lines, more efficient, and performed some lab experimentation to see if sodium fluoride and titanium dioxide could even be separated from that mixed acid waste. The results were as follows. The backflow is viable and had low cost, specifically a cost estimate for adding a backflow for the clean line I was thinking about was $400. It was estimated to save like $72 and save like 32,000 gallons of water a year. Closed was found to not be viable. The water they were looking out to take out to use that closed loop would have to go to a reverse osmosis tank, and it just wouldn't clean the water to enough purity to be reused. So that was not recommended. The drag out reduction potential was frankly very low. This was because best practice was already in use at the plant. There were some systems for reuse that were found. Specifically, we looked at spray roasting. What was it? Another reverse osmosis system, and a system called beta control, which was essentially an evaporator attached to a condenser. The spray roasting system was found to be unviable because it just turned all the mixed acid to NOx. The reverse osmosis system was found to be unviable because the acid was so corrosive it would just chew through the mesh. The beta control system, however, had potential because it was specifically designed for this mixed acid waste mixture, and it was found to. It was a very high capital cost. The system itself would have costed $200,000 if implemented. However, from the mixed acid you would get out of it, and from the savings from the reduced waste, it would have found to save about $100,000. So ultimately, this project was recommended because the ROI would have been around 2.2 years. It was also found through chemical analysis through adding sodium hydroxide and performing some filtration that titanium dioxide and sodium fluoride could be made, but could not be separated. Now, this was also because the chem lab at the Parsons facility was very basic. The only things on hand was a boiling plate and some filter paper. It is very likely that there, with more complicated equipment, you could in fact separate out these two products. The other thing that happened that was noted from the previous intern was that a lot of these parts were sleeved in these plastic bags before they're shipped out. There's a lot of overhang, as evidenced by this picture sometimes. This is because this is partially due to the fact that, generally speaking, the operators intentionally add on 5 inches of overhang, and they need to do this so they can sort of fold it back over and close the bag, so to speak. However, for curved parts, they sort of have to like guess the length because they don't really have any way to measure it. And so that sometimes means they sort of overestimate how much plastic sleeving they need, which is how you get results like that. Specifically, it was mentioned last year that it might be looking at like to create a giant table. That was decided to be a little unfeasible because it might slow down the process. I decided to look into whether there was maybe like a shorthand they could use, like a quick equation that they could just plug in the width of the piece so they could figure out the curve length. Did some data measurement, found that the pieces were just too inconsistent, like were just too diverse, and there was just no shorthand that could be made. Ultimately, the sort of like index of with this part measure out this length would be correct. And that was found to be feasible because the parts themselves were marked at the plant. So the operator could look at the part and sort of input it into a program and it would maybe spit out like the correct length. And that was decided to be the sort of best option to reduce plastic overhang. This would have saved the plant about $627 a year and reduced carbon emissions by some small quantity. Probably the most interesting thing about the process was how paper heavy it was. The plant uses thousands of pounds of paper a year due to the work order system. Specifically, when they get an order for how to make a part, they have to print out an entire instruction sheet for the operators on the floor about what to do. This instruction sheet can be hundreds of pages long, and that's for every single individual order that comes through. The proposed solution for this was going paperless. I talked to IT to determine what would be needed to go paperless. Specifically, they would need like an extra IT guy, and they would basically need to get a bunch of iPads and a new ERP system to make this feasible. The good news is that they were already planning on implementing a new ERP system that would handle this. So honestly, even if I didn't recommend this, this probably would have happened anyways. But this does show that while they do probably will go paperless at some point, this probably will take a while just for this new ERP system to be implemented, and the training to make this happen would probably take quite a bit. However, if they did implement such a paperless system, they are expected to save something like $30,000 a year and prevent like 5,000 pounds of paper going to the landfill. Finally, I was looking at chemical substitutions for the various chemicals going in. Truthfully, there was not much opportunity. Half of this was just due to customer specifications. You can't replace the hexachromate paint because the hexachromate paint is required by the customers. Many of the other chemicals there were frankly pretty harmless, like the dry lube they use is just graphite, it's just carbon, that's pretty inert. They use argon gas for the presses, that's also an inert substance that's not really a problem for the environment. However, there was one opportunity that showed up. Specifically, during the packaging process, they use a foam called polyurethane. This is created by a spray gun that is just a mixture that sort of mixes two chemicals. Then they're just called A and B, just like that's the industry term for those chemicals. And it'll create this foam. Some of the B components, depending on the polyurethane used, has hydrofluorocarbons. That's a pretty nasty greenhouse gas. So I sort of did a quick search to see whether the B components that they used at the plant had hydrofluorocarbons. And the short answer is one of them could confirm that one of the suppliers could confirm that theirs was water-based, did not have the hydrofluorocarbons. The other one could not confirm one way or the other whether it had hydrofluorocarbons. So I ultimately recommend stick with people that you know will not have hydrofluorocarbons in their Part B components. Another interesting thing about the Parsons site is that they provide free water bottles to all their employees. This is simply put because the manufacturing floor can hit temperature up to like 116 degrees Fahrenheit, and that's just on a normal day. Because that can cause potential health issues, they provide free water to make sure everyone stay cool. However, because Parsons does not have a water bottle recycling site, all those water bottles do not get recycled. Instead, they get landfilled. The proposed solutions that I looked into was shipping it to Pittsburgh, which is about 45 minutes away, because they do have a recycling center that does water bottles. Or I said you could offer filtered thermos flasks for the office. The reason why they would need filtered thermos flasks is because, quite simply, gets very hot in there. So you would need a thermos to keep the water cool. And also, a lot of the employees mentioned that the tap water there was kind of bad tasting. So the filtered part would hopefully remove that problem. The results found was the filtered thermal flask would work probably for the office workers, but for the manufacturing side of things, if implemented, that would save them about $2,000 and prevent a noticeable amount of plastic going to landfill. Also recommended that they might consider shipping this stuff to Pittsburgh directly. That is something that they ship parts all the time, so it'd be very easy for them to just contact someone and say, hey, we have all these plastic water bottles, can you ship it to Pittsburgh, Kansas? It was found to cost between $800 to $1,400 a year, depending on how they did it. Honestly, that sounded like pretty small overhead for a company or for the site itself. So I said, this is pretty small overhead. You pay me 2 weeks than this would cost. So I figured that was a pretty reasonable way to reduce the water bottle usage, was just to send it to an actual recycling center. Also, this was a pretty small project I did, but there is a part of the plant called the old offices. It is completely abandoned. there was a running fridge in there. I know it's not being used because when I opened up, I found a 3-year-old expired cheesecake. So I asked the regional health and safety person whether I could just clean out the fridge and turn off, and they said yes. And about an hour later, I had it cleaned out and turned off to save them about $50 a year and prevent about 547.5 kilowatt hours being wasted a year. Ultimately, there were also a few other projects that showed to not really have potential, but could that would either require more research or maybe a little more refinement to implement. First of all, with the abrasive reuse, the company uses a water jet system to cut titanium parts. The water jet uses a combination of water and abrasive garnet. This produces a lot of waste, and it costs the company a lot of money to dispose of this waste. There's a lot of like secondary and tertiary greenhouse gases that are associated with this waste, especially like shipping and just mining the garnet itself. So if you can reuse the garnet, that has some environmental potential. However, it was found that water jet waste was a little too fine to be recycled, and that there just wasn't anybody in the area that would be willing to pick it up and take it. However, it was noted that the garnet, especially spent garnet from water jet, is useful for growing roses. So if anybody can find a rose grower to take this up, they might have a potential customer there. As mentioned before, titanium dioxide and sodium fluoride can be generated from this process. However, you would still need to find a way to separate it out. And there is potential to add a new product stream at the site that would also reduce the amount of waste because you would be converting that waste into a product. Another potential option is sort of getting rid of the small fans around the floor. The site gets very hot. Unsurprisingly, the operators have put up a lot of fans around the place to cool it down. However, it has been mentioned that the heat generation from these fans might be contributing to the problem. If it was found that these fans are actually more of a problem than what they're worth, then taking down these fans would save some energy for the site. And finally, a lot of forklifts and carts going around the plant just because they have to move parts from one site to another. If they could find a more, let's just say, environmentally friendly version of those carts and forklifts, that would certainly be a project worth implementing. Here's a summary of all my projects. Some of these were not mentioned because they were frankly just not recommended, notably solar panels and I think adding door sweeps to the big break room. And some of the masking stuff I was looking into, that ultimately it was either found to be that it would maybe pollute more to implement the changes than it would prevent, or that it was just simply unfeasible from a financial perspective. And also, just because I don't have a slide here, and I've noticed this in a few of the other presentations, the things that I liked about the internship was it was very hands-on experience. I got to learn about a lot of things because I was essentially told to find projects. I was basically let loose to go find those projects and work on that. Can be sort of hard though, and this isn't really anybody's fault though, is that sometimes it is hard to talk to people, although that's not because people were mean or anything or didn't want to talk to me. It's just that people tend to get very busy. So sometimes it's hard to sort of ask people, how things are going, or to have 10, 20 minutes of their time because they often have other things that they need to do. Any questions?
Specific acid they use?
They use hydrofluoric and nitric. Yeah, HFHNO3. Oh, sorry.
No, you're good. Can you go back to the spaghetti thing?
Oh, yeah, sure. Oh, wait. No. There you go.
So, products will go back and forth to different areas.
Yeah.
They might start up near the red box, and go down and come back up to that area.
Yeah, and so the reason for that is that at different stages, usually, how do I explain this? There's a lot of handwork associated with this, where an operator will have to grind something down, we'll send it off to a few other processes, and then after those few other processes, it has to be grinded down again. So yeah, there's a lot of back and forth. Yeah, it kind of goes all over the place.
Yes, get comments supply, where do you know?
I know Ducommun supplies all of like the quote unquote big aerospace companies. Like when I was looking at their main website, they're talking about like Northrop Grumman or Boeing, and I want to say Spirit might even buy some stuff. I know you guys send an audit, so yeah. So it's in actually my final, like one of the first things, like here's who they all supply. So
I just had a couple other questions, but it's on for other people. Anything on line changer? Okay, great. So Michael, last year I remember Sophie identifying a heavy metal contaminant. I think it was going into their baths, either that or it was ending up in their sludge. And they were trying to figure out where it was coming from. I thought maybe the baskets themselves. Do you know if that might have been resolved in between the time Sophie was there and you were there? Do you know if that change happened or?
I frankly don't know. It probably was the baskets. Talking to the other people, they did say it was probably the stainless steel. Where the lead was coming from, honestly, that could just be Parsons Lake, because Parsons Lake has an abnormally high lead concentration. So part of this probably like Parsons Lake and old piping is probably where that was coming from. And Parsons Lake is where they draw their water from. The chromium, I don't think they've replaced any parts, but again, it probably is the stainless steel and those.
Yeah, I was curious if that had been implemented. I didn't know if you've done follow up yet or not.
No, I have not heard of any follow up on that. It might have been resolved, it might not have.
And then are they doing any? They have any recycling available to them? Because I know, surely Andrew is like recycling everything.
So yeah, so like the pallets are recycled, the metal scraps are recycled. Paper has to be shredded by guidelines, and that has to be disposed of in a special way.
Sure.
So if they could, they probably would, but can't, because of regulatory reasons. Again, it's really the plastic water bottles is the thing that like they could recycle but haven't, and that's again, Parsons does not have a recycling. So
and realistically, there's not very. I mean,
yeah.
But what was the ESG report?
Okay, so Environmental Social Government Report. Ducommun sends this out. I mean, I know they sent one out in 2021. It's saying, here's the way Ducommun is going to make the world a better place. They outlined some key like environmental like goals that they want to reach. Like they want to reduce their amount of greenhouse gas emissions, scope 1 and scope 2 by like 17%. And they wanted their Arkansas site to reduce their water usage by this much percent. And so this was just something I think that was like sent out to like investors saying like, here's what we're doing to help the environment.
Yes. So the enterprise resource planning system that they're thinking about changing over. I know in previous manufacturing positions tried to implement paperless on the shop floor. It can be rarely daunting challenge.
Yeah.
And a lot of times can't go fully paperless. There's always some kind of
Yes.
So on the calculations, you assume fully paperless or
no, I did not. What I specifically said, and I didn't include this in the PowerPoint, is I said the thing that probably could go fully paperless is the work order system. There is obviously going to be some paper left over because there's other paperwork. But I talked to the operators and they said they would assume that about 90% of the paper comes from this work order system because it really is 150 pages for one order. And I said, if you An ERP system would get rid of that because in that case, you would just need one paper with a QR code. You could scan it and that would just bring up all the instructions and all the relevant information. And so you would probably, so I said, I assumed that with a paperless system, you would reduce the paper usage by about 90%.
I would say you guys pretty well paperless. No? Oh.
We do have pretty significant part of the market system actually where the part identification is actually printed on the part itself rather than on like the case that the parts are. And that can identify it, but as far as what you're talking about in terms of QR code system, we do not have that.
Yeah.
We do actually have, because we're such a huge facility and we have literally hundreds of hazardous waste containers throughout the facility. Our hazardous waste is actually all of our rigorous inspections, stuff like that, is all done through QR.
Yeah.
In fact, since very few of us are cleared for some of our defensive work, people in my department rather than the contractor have to actually do the inspections and work with the system to QR codes in our secret area. Worked out really well there. Literally millions of parts flowing through the facility. So yeah, we've always been trying to update the system.
Jacob, you were saying though that your former company.
Yeah. So former company electronics for this space. So yeah, all the parts do have bigger wrappers, top workers that make big, and fortunately in that case, we didn't have workers in which is a bit of operation. But when I did going, they could just finish swapping over to different parts, and that itself is being gigantic.
Oh yeah, no. When they were talking about, they were like, "This is something that would make the plant so much better." Like not just from an environmental standpoint, but just like so much more efficient. But like they also said, this would be a years-long process between the training and like getting everyone updated. And they said they wanted to wait till the new ERP system came in, and they also said they were waiting for CMMC to be implemented, which is a new DoD regulation that regulates printers of all things. I can, so not much, but the DoD said if you are making parts for the military, or they put out a new guideline, the way I've heard is that they wanted to reduce the number of printers. They wanted to specifically, or at least not reduce the number, but they want to regulate how printers were used. Specifically mentioned that they were worried that people were going to be printing off stuff and, you know, on a printer just sort of comes out and like, you know, anybody can grab it. So they were worried about that. So they said they wanted printers that would require you to scan the, before it released the papers. So it would know that it's only the person who was qualified to take that paper was going to take that paper. And I think the Parsons plant noted they want to reduce the amount of printers because that would, because otherwise it'd be really big hassle to implement CMMC. I forgot what CMMC stand for, but it's DoD related and it would have impacted printers.